Here is a new Seagate hard drive. Model, ST1000DM014. PN, start with 2U. Date, August 2023. Let's take a look at PCB version 100.870.255. From the software test we find that boot code mode is unable to read ROM. Actually, current product series often starts with 2U in PN. When coping with it, we need to use physical desoldering method. Combine it with ROM programmer to read/write ROM. We have prepared a ROM programmer. After taking off PCB, we first need to confirm which one is real chip. Then we have to solder it and put it in ROM programmer. The programmer has been connected to MRT card. ROM chip is well placed. Note, the dot on the chip should point to the middle of programmer. Now we need to operate ROM in MRT programmer program. Current MRT version is 2191. Enter programmer tools. Chip model is detected successfully. The log and ID display 2048 KB capacity. When reading fails, please adjust placing of chip. We first read 32 KB to fast confirm data result. Generally, we don't know the actual ROM size. We recommend to save 1024 and 2048 KB ROM size. Current chip capacity is 2048, we choose 2048 size. Note, when it fails to read ROM at the first time, it will repeat reading twice. When it reports error again, please adjust chip contacts. Enter programmer program again to identify chip. Reading 2 MB ROM size will take 2 minutes and writing at least 4 minutes. Reading completed. Create new folder and rename with disk model. Respectively save 2048 and 1024 KB ROM files. Current chip capacity is 2048. We switch back to 2048 size. Go back to main interface and enter Seagate F3 utility. When we are unsure of real family ID, select random family and enter it. Since we need to unfold ROM file, we go back to programmer tools. Copy the ROM path. Paste the path in ROM tool. We choose 2048 ROM file first. CAP wrap SAP are normal data, so ROM size is correct. When CAP wrap SAP report errors, it proves that ROM lacks data. So we know the correct size is 2048. Now we learn how to confirm Family ID. The most of ST drives recognize Family ID from SAP. A few refer to CAP. We refer to SAP as priority, and now we need to choose D1 family. Here we recommend to rename with real model. Unfold correct ROM file in ROM tool. We recommend to save ROM as backup. Click Firmware Unlock and confirm the result. Save the unlocked ROM. The actual repair often considers virtual start. Current function is unable to create virtual ROM directly. Version 2191 added an option here. We open it. Select original ROM and create virtual boot. In current folder it will generate a virtual ROM file. Now we have 3 ROM files. The general method is to use unlocked ROM to read resources including system file 20D. When virtual start is needed, dolder ROM chip and write virtual ROM. Now we copy current path and go back to Programmer Tools. We need to write unlocked ROM. It is recommended to save both unlocked and virtual ROM into Programmer directory. Select unlocked ROM. Note, when writing to chip, we have to ensure same writing size as last reading size. As for 2048 KB chip, there is a parameter setting. 10,000 means 10 seconds waiting time before erasing the chip. For 1 MB and below, setting a lower value is OK. Click Write button. After 10 seconds, it starts to write data. Note, before writing, program needs to send a erase command. If the chip starts writing data before it is fully executed during this period, it may result in data being only partially written. Or if the data is logically written bad, additional time is needed and a second write is required. So waiting time of 10 seconds is actually as much as possible to accommodate 2 MB chips. Data writing completed. To ensure data consistency, we need to reread ROM for comparison. After saving ROM, we use WinHex to compare unlocked ROM with reread ROM. Verify the data consistency. After verification, we need solder ROM chip back to original PCB. Now ROM chip has been soldered back to PCB. We restore the hard drive and connect to MRT device. Since it is unlocked ROM, disk keeps staying at busy status. Manually enter Seagate F3 utility. Ensure physical terminal connection and select COM port. Power off and on, MRT unlock sign appears on terminal window. Click Exchange commands. After getting ready status, identify family and enter program. Drive is ready, so we recommend to save all HDD resources. Due to long time waiting, we uncheck system files for quick backup. Remove certain larger modules and modules that are prone to errors. Now we consider backup operations under busy status. When disk gets busy, we mainly operate system file list. It is recommended to use serial port to obtain system file list. The default baud rate will be set to 460,800. The common read modes are ATA and COM mode. We demonstrate to use COM port to read system file 20D. We advise to use 460,800 baud rate each time. Because drive is ready now, we demonstrate to use ATA mode to read common system files. Now we learn how to create head map for Seagate drives. Enter Data Explorer module and create data copy task. Click Create Head Map. Both two methods can be tried. There is an option. When the value is not 0, we'd better select it. The rest of situations take default. Note, head map requires activated ST utility and it is not occupied by other windows. When head map fails to create or is incorrect, we need to refresh these parameters here. Now we make some suggestions of settings.